Morning, YouTubers. John Gilkison, Aero Stealth here, and it is Friday, April 10th, 2026, and I just have a short video for you this morning on standby losses when you're charging your electric car. I watched a video on YouTube the other day where a fellow had better measuring devices than I have access to, a dongle and an app and amp meters and stuff. And what he was demonstrating was that when you're charging your car, charging efficiencies is really about what the car is using when you're charging it. In other words, the mere act of plugging it in kind of powers up the car because it's got to run the inverter, and it's going to have to run cooling loops or heating loops for the battery. In the wintertime, the battery might need to be heated. In the summertime, it might need to be cooled. And there's other ancillary loads. There's the computer, of course, that's running, which is tracking all this stuff. And these are what I would call the standby losses. And they vary throughout the year and from car to car. But, so you need to get anecdotal, you need to get specific here. So, and one of the figures he quoted was basically 300 watts. And I've seen that before. When I owned a Chevrolet Bolt, I think it was always telling you that it was using, when I turned it on, it said it was using 1 kilowatt. But that's a rounding error. So I've never had access to this data in more detail, more decimal places. But let's go ahead and assume 300 watts. So, and I used to own a Chevrolet Bolt, and I sold it to a friend, and he's still using 120 volt charging. And this is why this problem's been bugging me, because I sold him a 120 volt EVSE, but he hadn't gotten around to hooking it up, and he's owned the car over a year now. So here we are, and I just ran some numbers here at 120 volts on a 15 amp circuit. And then the other numbers was 240 volts on a 40 amp circuit, and also on a 48 amp circuit. Now what you have to understand is if you're plugged into a 15 amp circuit, there's an 80% rule with all electrical circuits for continuous loads. So, and charging is a continuous load. You're constantly taking powers for hours on end. So really, 15 amps, you can only charge at 12 amps. On a 40 amp circuit, you can only charge at 32 amps. And on a 60 amp circuit, of course, it's 48 amps. So here's just some of the numbers I just ran. And of course, I'm going to read this out to you because there's just too much for you to take in here. But I broke it down into those 3 charging scenarios. And we're assuming 300 watts is your standby losses. That's what the car is taking to just run itself while you're charging the battery. And of course, it's getting that power from the EVSE because you're plugged into a landline. Okay. So, at 1500 amps, you can only really pull 1.44 kW. And it's the 80% rule. And if the car's taking 300, that only leaves you 1.14 kW to charge the car. So in 8 hours overnight, I picked that time because I have a off-peak rate that's good for 8 hours from midnight to 8 a.m. All you can pull for charging your battery is 9.12 kilowatt hours, which is only going to buy you somewhere in the neighborhood of 36 to 40 miles of range for that car. Which, if you're not driving that much, of course, that's not a problem. However, and this is where I differ with most people, and I think a lot of EV enthusiasts want to encourage everyone they can to buy an electric car, and they want to say, well, if all you got is a 120 volt 15 amp circuit, you can still charge your car if you don't drive that much. And it's all true. It's not a falsehood. But here's what happens. If you're pulling 300 watts of standby losses over that 8-hour period, 8 times 300, you lose 2.4 kW to just losses, standby losses. And you're putting 9 in. That's like 26% of the power that you're paying for out of the wall is just going to standby losses, idling fees. And see, this is all has to do with the time constant. What's going to happen is you're going to want to charge this Chevrolet Bolt from, let's say, 20% to 80%. That's 60% of the battery. That's 39 kilowatt hours. Okay? And so that's just in an 8-hour period. So 9 into 39 is a little about 4.5 hours. So you're gonna lose about 9 kilowatt hours just to charge from 20% to 80% if you're charging at 120 volts on a 15 amp circuit. That's a significant amount of power. 9 kilowatt hours times, let's say, 10 cents is 90 cents. Times 12 cents, it's $108, $1.08. $1.08 in standby losses just to charge your car at 12 cents kilowatt hour. That's really unacceptable unless you really don't have any other alternative. Because you're way ahead of driving with gas, yes, I'll admit that. But it's not ideal. It's far from ideal. But as soon as you go to 240 volts on a 40 amp circuit, charging at 32 amps, you can pull 7,680 watts through that circuit, which minus 300 brings you down to 7.38 kW times 8 hours, allows you to put 59 kilowatt hours into a battery. And in that whole time, you still only lose 2.4 kilowatts in 8 hours times 300. 300 times 8 is 2,400. Now your standby losses are only 4%. Now here's the rub here, and this is give me a whole new way of thinking about this. Your standby losses are just a constant. So the faster you can charge, the less your standby losses are going to be. And the same is true at 60 amps, which is a 48 amp draw, and you're charging at 11.2 kW. Same thing. In 8 hours, you're going to lose 2.4 kilowatts. It's a standby losses. However, you're going to put 89.6 kilowatt hours in your battery pack. Let's say you're driving a Ford Lightning or one of those bigger pickup trucks and has a larger battery. That's 2.6% standby losses. So you can see where I'm going here. The standby losses are the same in every case, but the percentage, relative percentage, is what keeps going up. You keep getting more power into the battery with the same standby losses. Now this is not an exact truth. As I indicated at the beginning of the video, there are variables. Whether you're charging in the wintertime, summertime, batteries has to be cooled. The battery has to be heated. You have a little bit better case in the winter because the mere act of charging heats the battery. But depends on what kind of winter we're talking about here. I live in the desert Southwest, so our winters aren't too much to concern ourselves with. So that's basically all I have for you. When I winnowed this down for my friend, which I just explained to you, I told him it would take him 34.2 hours to charge from 20% to 80%. He would lose 10.26 kW in that time period. And at on a 40 amp circuit, he would 32 amps. He would only take 5.13 hours to charge the car, and he would only have 1.54 kW in losses on standby. So he's reduced his standby losses from 10 kilowatt hours down to 1.5, and that's because of the time involved. So the faster you can charge, essentially, the less time is involved for these standby losses to accumulate. So that's all I have for you. And I just think it's an interesting way to think about this problem that I don't hear many people talking about, except for this one guy I ran across. And I wish I had prepared a link for you. I may figure out a way to post it in the future. Take care, everybody. Bye-bye.